Thank you for watching this presentation on doing the little things in the propane industry to make it safe. We'll share a collection of tips and stories to give you better insight into our industry. My name is Chad Ackner. I'm the Technical Service Advisor for Dealers LP Equipment and the R.E. Michael Company. R.E. Michael has corporate headquarters in Glen Burnie, Maryland, while Dealers LP Equipment has locations in Davenport, Iowa, Louisville, Kentucky, Hickory, North Carolina, Jackson, Mississippi, Dothan, Alabama, and also Memphis, Tennessee. It's important to note that anything discussed today should not in any way be construed to override any of your local applicable codes, any of your insurance requirements, or any of your company policies. Anything referenced today is from NFPA 54 and also NFPA 58. Part of the reason that you're here today is because of Section 4.4 in NFPA 58 regarding the qualification of personnel. And it basically says that persons who transfer LP gas or are employed to transport LP gas, or whose duties fall within that scope of the code, shall be trained in the proper handling procedures. It also states that refresher training is required at least every 3 years. All propane installations must comply with both NFPA 54 and NFPA 58. Those installations must also comply with your local AHJ, or authority having jurisdiction, which may be a local code enforcement agency or a fire marshal. Company policies must always be followed, in addition to following manufacturer's instructions. Part of the code is to actually follow the manufacturer instructions, whether it pertains to NFPA 54 or NFPA 58. So that is actually written into the code. Always work safely, document everything that's performed during the installation or during the service work, and retain all documentation. A breakdown of the differences between NFPA 54 and NFPA 58 are that NFPA 58 will cover everything from the container all the way up until the outlet of the delivery regulator. Now that may be an integral twin stage regulator or a second stage regulator. NFPA 54 covers everything from the outlet of that very same regulator all the way inside the building. This presentation is basically a group of odds and ends, things that are good to know for anyone working in our industry, wondering why maybe you haven't heard this before, or maybe you have. These are also stories about what may happen if you don't do something. It's important to stop, think about what you're doing, and be safe, never to get complacent. The first tip is to make sure everyone in the field has a Rigo L545 serviceman's manual and also a Rigo smartphone app downloaded onto their phone. Both of these two items will help any technician in the field doing installations or service work, and they'll also help bobtail drivers in certain instances. Another recommendation is to make sure everyone has access to a NFPA 54 handbook and also an NFPA 58 handbook. I recommend the handbook version of these code books because the handbook versions include detailed illustrations as well as insight as to how certain codes are created and why they were created. Did you know that one of the leading causes of propane emergencies in buildings, and in particular residential buildings, is when a propane appliance is removed and the shutoff valve is not capped or plugged after the appliance is removed? This happens frequently in rental properties when a tenant moves out and removes their own gas appliance, leaving the shutoff valve closed with no cap or plug installed. The new tenant moves in, and either a small child or someone inadvertently opens up the shutoff valve and allows gas to enter the building. A good practice is always to make sure when you're doing your gas check and your installation inspection that all shutoff valves are not only closed but have a cap or a plug installed. This is an example of what a service technician may see in the field. This is not something that is safe, and it certainly doesn't represent a cap being installed on the shutoff valve. Not only do shutoff valves have to be in place and within 6 feet of the appliance, they also have to be accessible. And in this image, you'll notice that there is a shutoff valve installed within 6 feet of this fireplace. However, the fireplace has to physically be raised to access the shutoff valve. Again, that is not what the intention of the code is. The shutoff valve has to be accessible without having to move anything or have any obstructions in the way. This may not be something that you think of often, but never look into a pressure relief valve, in particular when responding to a service call where the customer is reporting a gas odor at the tank or witnessing the relief valve popping off. At any given moment, the pressure inside that tank could require that pressure relief valve to pop off, and serious injury can occur. Who can see what's missing here in this image? What's missing from this cylinder? What's missing is the correct cylinder valve. If you look closely at this cylinder valve, you'll notice that it does not include a pressure relief valve. Every cylinder is required to have a pressure relief valve. DOT cylinders are all required to have pressure relief valves rated at 375 psi. When installing underground tanks, always make sure that the regulator is installed above the highest probable water line and or vented above it. Also make sure that the relief valve on the multi-valve of the underground tank has a cover in place. Making sure these two components of the underground tank installation are protected from possible floodwaters will ensure a long-lasting installation. Make sure when installing copper tubing or inspecting a job site that the copper tubing does not come in contact with cement. Cement can be highly corrosive to copper and in some cases can deteriorate it to the point of creating a leak. This is an example of why always performing a leak check is essential. This was found instantly when the leak check was started. Any idea what may have caused this? Anyone performing liquid propane evacuations or pump outs must be trained properly. Part of that important training is to understand what a telltale is. A telltale is essentially a hole that's drilled in the cap of the check lock liquid withdrawal excess flow valve that allows the technician to determine if that excess flow valve has closed or not before removing the cap. In January of 2007, an incident occurred in Ghent, West Virginia, where a junior technician was not properly instructed on how to perform a tank pump out. There's a 23-minute video available on YouTube by searching Little General Store Explosion. I highly recommend, if you haven't seen that video, to watch it as soon as you have an opportunity. And again, I would like to emphasize anyone doing tank pump outs or evacuations is required to be trained properly in how to do so. So tragedies like this do not occur again. When this incident was all said and done, a total of 5 people lost their lives. If you're ever passing through Gent, West Virginia, I highly recommend you stop at the site on Flat Top Road and pay your respects. Before doing any pump out or evacuation, understand that heavy ends over time will accumulate in the bottom of any ASME tank. If setting up a tank for an autogas dispenser, always use a new tank, especially if a tank that has been used in service was used in vapor service. Again, any tank that's been used in vapor service previously will have a certain amount of heavy ends built up in the bottom of that container. Heavy ends can be pumped into the vehicle storage tank, which will result in major service issues. So what's wrong with this picture? Well, it appears as though a refill station was installed on a concrete pad with the required bollards around it for crash protection. The issue is that the bollards on the left side of the tank are too close. The requirement is a distance of 3 feet. The installer apparently installed a concrete barrier adjacent to the concrete pad. However, that barrier is too low. Just a reminder to always check with your local AHJ to verify compliance. And speaking of compliance, always make sure that propane cylinders are used for their intended purpose. If you have ever had to respond to the report of a liquid propane leak, you certainly understand it's a chaotic event. Well, to minimize the chaos and reduce the stress level, oftentimes there's a simple solution to being able to make the situation a much safer environment. The first thing would be to put on some PPE or protective clothing, safety glasses, and the appropriate gloves. Identify exactly where the liquid leak is occurring from the container. Saturate a towel or a rag with water and place it around the source of the liquid leak. The liquid propane will immediately freeze the water in the towel and slow down, if not stop, the propane leak on a temporary basis. Again, this is not meant for a permanent or long-term repair, but it does allow you to mitigate the situation and slow down the process so that a full evaluation can be made in a much safer manner. This may sound like a joke, but it's really not. Oftentimes, a dog will urinate on a propane tank. The urine has ammonia, which will actually corrode the steel on the tank. There have been reports of this situation happening in which the tank will actually corrode through, resulting in a liquid leak. Something to be on the lookout for when making deliveries or doing tank inspections. Sometimes overlooked is the installation of a hydrostatic relief valve. Hydrostatic relief valves are devices that are installed in any liquid piping or hose in which liquid propane can be trapped between shutoff valves. This could occur at a bulk plant, a refill station or autogas station, a bobtail, or even a vaporizer or air mixing installation. The reason that hydrostatic pressure relief valves are so important can best be explained here. This is an example of a site flow indicator that you may see at a bulk plant or at any sort of liquid transfer facility. This is a fitting or a device that's installed in liquid piping and most often installed between two shutoff valves where liquid can become isolated in this piping. If a hydrostatic relief valve is not installed in this system, this is an example of what can happen. Manufacturers indicate that these site flow indicators are tested at a pressure reaching 2500 psi. Use extreme care when pulling propane delivery hose around the corner, whether it's a brick foundation or any sort of an obstruction that may cause damage to the outer layer or skin of that delivery hose. That can rupture the hose, resulting in a safety hazard. If you've ever delivered propane in the rain, you've probably noticed intermittent bubbling occurring through the outer layer of the hose. In some cases, this is normal. Some manufacturers will put pinholes in the outer skin or the outer layer of the delivery hose. What the pinholes are required to do is to relieve any vapor pressure that builds up due to propane migrating through the inner layers to the outer skin or the outer jacket. Currently required in some countries is the SFL 7579V. This is essentially a 1 3/4 Acme fill adapter with an OPD valve connected to it. Will this come to the United States as a requirement in the near future? Here's a second stage regulator installation that has a few issues. What do you notice here? The first issue is that the regulator is less than 12 to 18 inches off the ground. Next, there is no flex connector connected from the outlet of the regulator to the inlet of the generator. And last, the vent material connected to the second stage regulator is non-UL 651 spec. Here's another generator installation with some regulator installation issues. The first thing is that the termination of the remote vent is too close to the ground. Secondly, the vent material is non-UL 651 spec, which is the gray type electrical conduit. Third, the regulator is mounted on its side. Therefore, the upper bonnet case is not draining properly if and when condensation builds up. There's a shutoff valve, but the shutoff valve is after the regulator. The regulator is not supported off the ground, it's simply hanging there. The second stage regulator, ideally in any generator installation, should always be a LV 5503 series large diaphragm second stage regulator. And also, the vent termination is less than 5 feet away from the generator. By my count, that's at least 7 issues here. Always make sure to clean out any newly installed gas lines. Doing this will lower the possibility of any foreign material getting caught between the inlet nozzle and the regulator seat disc. If debris is caught on the regulator seat disc, it may allow pressure to continue building downstream and possibly open the relief valve on the regulator. This is often called creeping. Here's another refill station installation with some issues. If you look all the way to the left, you'll notice a box with firewood in it that's approximately 6 feet away from the tank. Under the left-hand side of the tank, you'll see that there's firewood there as well underneath the tank. And all the way to the right, you'll notice that there is a pallet and more firewood approximately 3 feet away from the point of liquid transfer. All 3 groups of firewood are required to be a minimum of 10 feet away from the tank and also the point of transfer. If you have a fill station, make sure all employees responsible for filling cylinders understand, first of all, how to fill a cylinder safely and properly, but also to understand what's required for responsible transportation of filled cylinders. Cylinders are placed in the hands of the general public. The general public does not necessarily have a good working knowledge of how to handle cylinders and how to properly maintain cylinders. Consumers look at you, the propane expert, to ensure their safety and proper handling and transportation of any cylinders that are filled. This image illustrates how important training is in our industry. Consumers rely on you, the propane experts, to properly and safely perform installations. This is an example of why it's important to have Regal multi-bonnets in your multi-valves. A Regal multi-bonnet will allow you to change the packing assembly on a bonnet of a multi-valve with product in the container. Without a multi-bonnet in place, the container has to be emptied prior to the exchange of the bonnet assembly. These are two examples of violations of Section 610.15 and 610.16 in NFPA 58. Those sections require regulating equipment to be a minimum of 5 feet away from external sources of ignition and 3 feet away from any lower window opening into a building. They also require containers filled on site, in this case the 420 next to the building, to be a minimum of 10 feet away from an external source of ignition. Always make sure regulators are not only vented 5 feet away from an external source of ignition, but also supported properly. Here's another example of a second stage regulator that has not been properly vented away from a pool heater. Here are 3 installations using Maxitrol line regulators. Which of these regulator installations is correct? The answer is none of them. These Maxitrol line regulators are designed to take an inlet pressure of 2 psi and regulate that pressure down to 11 inches water column. Additionally, these regulators are designed to be placed with a vent limiter vertical. In other words, the brass vent limiting device that's attached to the bonnet of the regulator. So by looking at all 3 of these images, none of them are installed properly. When servicing a propane installation, always be cautious about work that's been performed by others. Oftentimes, people that are not professionals will perform or attempt to perform installation work that is not necessarily up to code standards. Both NFPA 58 and NFPA 54 indicate approved piping materials for propane. NFPA 54 indicates approved interior supply pressures and also entry point locations. If you look closely at this ASME horizontal tank, what do you notice? You'll notice the incorrect service valve was installed. This cylinder valve was installed in place of the multi-valve that was originally installed in this tank. In addition to using a cylinder valve in place of the original multi-valve, which was installed in this container from the factory, the other issue here is that the relief valve on the cylinder valve has a set point or a set to discharge of 375 psi as opposed to 250 psi of an ASME relief valve setting. What do you see wrong or incorrect about this second stage regulator installation? And what about these regulators? What about this installation? The issue with all of those second stage regulator installations is the vent position. The vent position must be pointed down vertically, in other words, at the 6 o'clock position, in order to properly drain any condensate that may have accumulated in the upper portion of the bonnet assembly. The condensate drain, as per UL 144 specs, is designed to be installed behind the vent or the vent suppressor in the cavity of the upper bonnet on the regulator. The key is to always install the regulator with the vent pointing down as it was designed and built from the factory. In no way, at no time, should a bonnet be removed and rotated to accommodate this. Again, the bonnet assembly must be in the position with the vent pointed down vertically as it was designed and assembled from the factory. Altering the bonnet or any portion of the regulator will not only void warranty, but it will create a liability. Speaking of installing second stage regulators, there have been many stories about difficulties installing second stage regulators at generators and within the specification of the code. Working with Rigo, we've put together this scenario that may help in some situations. If a LV4403TR9 and an LV5503 B8VO, which is a vent over outlet 5503 second stage regulator, are piggybacked and installed at the container, it's possible that the low pressure line from the outlet of the second stage to the inlet of the generator can be sized appropriately to supply the generator. In these cases, the venting of the second stage regulator is not necessary because both regulators are at the tank. Table 7 of the Rego L545 features a second stage or integral twin stage pipe sizing chart at 11 inches water column using poly pipe. An example would be 50 feet of 1-inch IPS, providing a total BTU capacity of 514,000 BTUs at 11 inches water column. A typical 20 kW propane-fired generator consumes on average less than 400,000 BTUs at full capacity, indicating that there are certain scenarios where a piping installation similar to this would work very well. Always make sure that any container you connect to and fill is up to code. As an example, this installation does not meet the ESB requirements. Section 6.8.3 of NFPA 58 indicates that any horizontal ASME container designed for permanent installation in above-ground service shall be placed on masonry or other non-combustible structural supports. This installation pictured here is out of code. It's a permanent installation, permanent 500-gallon ASME container above ground installed on wooden planking, which is considered to be a combustible material. So with that information, would this installation be legal? What about placing containers not connected for use? In other words, when an account is taken over. Section 6.3 of NFPA 58 indicates that previously used storage containers must be left on the owner's blocks and also at a proper distance away from other tanks, buildings, and property lines. In other words, tanks should not be left lying on their side or sitting in the dirt. How about this fill station installation? Does this appear to be up to code? If there is ever a question on approved container installation locations, always refer to NFPA 58. Here's an example of an installation with multiple issues. First of all, the poly pipe has been installed above grade, above ground. Poly pipe is only approved for underground use. There also appears to be a hardware store style hose clamp attached to the poly pipe. Again, not approved for the LP gas industry. Also, when tandeming or connecting two containers together, the regulator must be at the outlet of the manifold. And lastly, the height of connected containers must be equal. Here's an example of a high pressure first stage line that was run across the top of a concrete pad to a generator. You'll notice if you look closely that the piping is actually poly pipe. Poly pipe, as we discussed earlier, is not allowed to be installed above grade, and in this case, the ultraviolet rays from the sun are directly hitting the one section. And it doesn't end there. The second stage regulator in this installation is loosely taped to a post, while the CSST that's connected from the regulator to the generator inlet is just simply hanging loose. The point is, always make sure any installation that you're servicing or filling is up to code. When any piping installation is done, it should not be left as a tripping hazard. Here's an ASME tank installation with numerous issues. To start off, we're less than 10 feet from the electric meter, which is an external source of ignition. We're less than 3 feet from a lower window opening. We're less than 10 feet from what the code considers to be an important building. The tank is set directly on the ground into the dirt, and we're also less than 10 feet from the outdoor AC unit, which again is an external source of ignition. We have another fill station that may not be up to code. We have a 1,000-gallon tank here about 5 feet away from the building and under a roof or a cover. There's also a dumpster full of combustible materials about 8 feet away and other combustible materials inside the fenced-in area or the caged-in area. All access paths to this tank are either locked or blocked, meaning any delivery driver filling this container, if an emergency occurred, would not have a means of egress. If the pressure relief valve went off, or if there was some other source for a product release, it would quickly accumulate inside that area. This is another example of what to look out for when selecting containers to fill. There is a requirement that the remote switch or circuit breaker for a fill station or dispenser must be labeled and accessible. The labeling must indicate exactly what the disconnect is for. In this image, you'll see clearly that this labeling is covered up. Make sure that yours is visible and in plain sight. Due to the vibrations caused by an internal combustion engine, propane generator manufacturers require the connection or the addition of a flex line or a flex connector at the unit. Generator manufacturers include this in the sale of the generator. If for some reason the flex connector is not included or missing, always make sure to install one. Never connect the propane line directly to the generator without the flex connector. If you have a propane fill station, always make sure the customer's mode of transportation will meet DOT expectations. When servicing, filling, or taking over a propane account from another provider, always make sure that the tank installation as well as other components such as regulators and things of that nature are installed per NFPA 58 requirements. Once a propane system is serviced or filled, it becomes the responsibility of the providing company. As mentioned earlier, both NFPA 54 and NFPA 58 require installers to follow the manufacturer instructions. Here we have CSST that's been buried below ground. And while that is acceptable, manufacturers require CSST to be installed or encased in conduit if being buried below grade. Both gas tight and track pipe require this to be done at installation. Check with your local authority having jurisdiction to see if this also includes the new style direct burial CSST. A simple pipe wrap is not considered conduit. When we talk about cathodic protection for underground containers, we talk about the importance of testing all four sides of the container once it's in place. With that said, will this image on the left work for the proper cathodic protection? The answer is no. The half cell, which is used for testing purposes, is required to contact the soil or the electrolyte, the same environment that the container is sharing with the anode. In other words, the tip of the half cell, the copper sulfide half cell, must enter the soil where the container is residing. It's important to point out that polyethylene piping is not allowed to be installed above grade, and the reason for this is to keep it out of the UV rays. The ultraviolet rays from the sun will have a dramatic deteriorating effect on the piping itself. It's also worth noting that when polypipe is being stored, it should always be placed indoors, out of the sunlight, or under a protective tarp. Here's an image of corrugated stainless steel tubing being connected to a transfer valve and also connected to the liquid withdrawal excess flow valve on a container. Most likely this container is providing liquid to a piece of crop drying equipment. Unfortunately, CSST is only rated for service up to 25 psi. Therefore, this installation is out of code. Always make sure that any installation you're connecting to or servicing meets NFPA 58 and also NFPA 54 requirements. And here's a similar example. Here we have CSST being sleeved in PEX water piping run in electrical conduit that's connected to crop drying equipment. Again, this is outside of the scope of what the CSST is rated for, and therefore this installation is out of compliance. Here's a picture of an improperly installed drip leg or sediment trap. In this image, the gas vapor coming into the appliance will essentially just float over or drift over the leg on the sediment trap. Any debris or moisture that's designed to drop into that trap or that leg will ultimately make its way into the inlet of, in this case, the line regulator that's installed in this appliance. Always make sure when installing drip legs or sediment traps to install them so that the propane vapor flowing into the drip leg is able to drop any contaminants or particulates into the leg of the trap before that propane vapor enters the appliance. And here's an example of a direct-fired propane water heater that was also installed out of code. For starters, we have a displaceable shutoff valve, and again, those are not allowed in gas installations. If you check section 9.6.5, all the details will be available. We also have PEX water tubing that was installed in place of a flex line. And lastly, we have a missing sediment trap or drip leg in this installation. All of this information and all the details as to why this is important is included in NFPA 54 and in particular the NFPA 54 handbook. In 2019, OmegaFlex or TrackPipe released a letter stating that anytime CSST was exposed to floodwaters, it was required that that CSST piping be replaced. This image that you're seeing here was taken from the Mississippi Delta after a storm, and the image was taken with the question to the local authority having jurisdiction about this very thing. If you are ever called to service an installation with CSST that has been subjected to floodwater, understand that that CSST must be replaced. Who can identify what's wrong with this installation? Well, first of all, this 500-gallon tank is about 4 feet away from the building. A separation of 10 feet is required. This building also houses electronics and an electrical power substation, making the situation even more critical. This is clearly an important building based on the definition in NFPA 58. And also, even if this is a fire-rated wall, there is no provision in section 6.4.1.1 for reducing any of that separation requirement for a fire-rated wall. Always install the correct polypipe gas piping with designated polypipe fittings, regardless of the manufacturer. The SDR or wall thickness of some of the PEX water piping and the chemical composition is significantly different. In cases like this, if the wrong piping is used, leaks will occur. There's a few important things to point out if you're installing 2-pound systems. If you're using Maxitrol line regulators in those installations, and also if that line regulator is going indoors, Always make sure that the vent limiter is pointing up or vertically. If the line regulator is going outdoors, make sure you exchange the vent limiter for a blue plastic vent protector, which will keep the rain and any other debris out of the regulator. Always adhere to single appliance BTU limitations. Make sure the gas, which is stamped on the bonnet of the line regulator, matches the type of gas you're using in this installation. And also position the inlet and outlet of the line regulator correctly. Always make sure to adhere to the bonding requirements of CSST in NFPA 54. Here's an example of what can occur to CSST if it's not properly bonded. What about sizing containers in order to make sure they will vaporize enough product to supply the appliances? On page 8 of the Rigo L545, there are instructions on exactly how to size an ASME container for a particular job. And speaking of container sizing, and in particular when we discuss generator installations, always refer to the manufacturer installation instructions and also the data plate on the generator to verify what the consumption is. Oftentimes, a 20 kW propane generator will consume upwards of 400,000 BTUs an hour. So therefore, if the generator is consuming that much product at full capacity, the containers must be sized to provide that in addition to whatever else is connected to propane in that system. All new and reconditioned propane containers come vacuum purged or with a negative pressure on them. It's important to make sure that not only methanol is introduced to these containers before going into service, but also they're placed into service properly. Introducing 15 to 20 psi of propane vapor prior to introducing liquid is highly recommended. If a propane container is found to be at atmospheric pressure, there's a high likelihood that both air and moisture are inside the container. This needs to be resolved. So therefore, conventional purging methods must take place. In this situation, prior to placing the container in service, proper purging with 15 psi of propane vapor and then releasing it into the atmosphere 4 to 5 times is required. On page 12 of the Rigo L545, all of this information is detailed. Methanol application to remove any moisture in the container is also critical. Whether preparing new containers for service or simply maintaining existing storage, always make sure that 99.85% pure methanol or anhydrous methanol is used. Avoid any substitutes. Always make sure anytime transporting or storing cylinders to make sure that they're upright, make sure the relief valve is always in communication with the vapor space, make sure they're secured, and also make sure the cylinder valves are properly protected. We often see that propane delivery tickets have the name, the address, the product being delivered, the delivery instructions to the building. But what about this? Do your delivery tickets have a check mark to indicate that the propane has been properly odorized? This is required to track the chain of custody for ethyl mercaptan additives. If you're not installing 2-pound systems, here's an example that might make you think again. Here's an example of a 40-gallon direct-fired propane water heater installed with a 420 and about 40 feet of half-inch copper tubing. That has a BTU capacity of about 44,000. 10 years go by and the homeowner decides they want to replace that unit with a new tankless water heater. How is the piping that was originally sized for 40,000 BTUs going to supply a nearly 200,000 BTU load? Well, the first option is to remove all the piping and install either 3/4 inch black iron or 1 inch CSST. That can be costly and labor intensive. Option 2 is to replace the existing regulator with an integral twin 2 psi and also install a line regulator prior to the water heater inlet. After all is said and done, this simple 11-inch water column to 2 psi conversion puts the tubing at a BTU capacity of 402,000 BTUs. And remember, previously it was only set for 44,000 BTUs. That's approximately 9 times the difference. Here are some conversion examples going from 11 inches water column to 2 psi. 40 feet of 3/8 copper tubing at 11 inches water column goes from 21,000 BTUs to 195,000 BTUs at 2 psi. 70 feet of 1/2 inch copper tubing at 11 inches water column goes from 32,000 BTUs capacity to nearly 300,000 BTUs at 2 psi. 80 feet of 19 EHD 1/2 inch CSST goes from 52,000 BTUs at 11 inches water column to 393,000 BTUs at 2 psi. And lastly, 100 feet of 3/4 inch black iron pipe goes from 175,000 BTUs at 11 inches water column to 1.61 million BTUs at 2 psi. That's approximately a 9 times increase from 2 psi to 11 inches water column. Be mindful of installing propane containers under open stairways in cold weather regions or near sidewalks. And the reason for this is because often salt is applied. When the snow or ice melts and the salt water or the ice and salt mixture drips on the container, corrosion will occur rapidly. Part of your responsibility before filling any container is to make sure to check the tank base or the footing before filling. There have been examples that tanks that were not properly checked with inadequate tank legs or bases have failed, resulting in instances or accidents. NFPA 58 handbook goes into detail about some of these occurrences. And the same goes for any construction site cylinders or temporary heat cylinders. Always make sure the foot rings are solid and able to support the cylinder upright, and also make sure the cylinders have protection collars in place. Never fill a DOT cylinder that is in need of requalification. There are many examples in the NFPA 58 handbook highlighting this exact thing. Here's an example of why cylinders that have not been requalified should not be filled. This is an image of a vehicle with a cylinder in the back that was built in 1979. That is obviously years before the OPD valve was required. It was later determined that the individual filling this cylinder filled it liquid full, placed it in the trunk of the car laying down. Therefore, the relief valve was not in the vapor space. The relief valve at some point during the commute back to the house opened, caught the car on fire, and severely burned the driver. This is a classic example of why anyone using fill stations and operating fill stations should be required to be thoroughly and properly trained. Learning the specific gravities of both propane liquid and propane vapor is important. It may not seem like it, but just understand that even a full propane tank can and will float in the right conditions. Containers that are installed in designated flood zones or near bodies of water that have the potential to rise and flood should always be anchored, whether it's to the soil or into a concrete pad. It cannot be stressed enough the importance of working with your local emergency first responders, conducting training at fire departments, doing plant tours, familiarizing any first responding personnel to how a bulk plant works or a bobtail works and where the emergency shutoff valves are is very important. Sometimes overlooked is the importance of replacing pressure relief valves on your bulk storage. Here are some images of an incident that occurred in 2017 at a bulk plant in the Midwest. In this particular case, the internals of one of the relief valves had blown out, resulting in a 5,000 to 7,000 gallon product loss. In this instance, you can see where the tank frosted over, the piping frosted over, and ultimately the pressure was reduced based on auto refrigeration and a pressure drop, allowing the repairs to be made. The point of this slide is to showcase the importance of changing bulk plant relief valves every 10 years as required by the manufacturer. In this particular case, the relief valves that were installed in this bulk plant were approximately 35 years old and had never been maintained. How do we get from this, a seemingly normal, straightforward propane ASME container installation, to this? A BLEVE, a boiling liquid expanding vapor explosion, is something that none of us ever want to experience. However, this one that you're seeing here occurred in 2022, and it showcases the sheer devastation of what happens to the surroundings when a BLEVE occurs. A BLEVE is the result of an uncontrolled amount of heat being applied to a container. The pressure relief valves, which are designed to be installed in every propane container, cannot simply keep up with the amount of heat that is being applied to the container. Generally speaking, the relief valve will open, attempting to relieve whatever pressure it can from that container to keep it safe. However, because of certain environmental conditions, possibly the fire department running out of water, or simply there not being adequate water on site to keep the tanks cool or the tank cool, what will happen is a catastrophic failure of the steel in the vapor space of the container. Where the wetted surface is inside the container, or where the liquid is in contact with the inside of the tank, the liquid is able to keep that steel cool enough so that it doesn't weaken. However, if the uncontrolled heat source is touching or coming into contact with the vapor space of that container and the ability to cool the tank fails, then what essentially happens is the tank will weaken in the area of the vapor space and ultimately come apart. Here is an example of how a lifeguard safety hose works. This example resulted from a driver that attempted to pull away from the bulkhead, resulting in the hose becoming severed. In this case, the lifeguard smart hose immediately shut the flow of gas off and made the situation much safer. For details on how to conduct a fire safety analysis for installations over 4,000 gallons, refer to the NFPA 58 handbook. Component failures at refill stations and auto gas dispensers can and will occur. This is an image of the internal components of an excess flow valve which dislodged and actually stopped the flow of product through the dispensing station. Don't get complacent with your fire extinguishers at your bulk plant or at your facility. Know where they are, know where they should be. Are they ready to be used? Are they properly charged? Does everyone involved know how to use them? And are you getting them serviced annually? Make sure anyone frequenting or working at a bulk plant understands the proper operation of an ESV or an emergency shutoff valve. Understand the flow direction and understand the operation and how to close and open these valves. Also make sure there's proper signage in place for the ESVs. Make sure that the push to close or pull to close verbiage matches the operation of the valving at the plant. Also make sure that the ESVs and the switching is tested regularly. Make sure that you're participating in duty to warn, which is our responsibility as a propane industry to properly instruct and inform our customers on the safe operation and potential dangers of propane installations. Customer communication in our industry is very important. The consumer relies on the propane industry to be the experts. Therefore, duty to warn, promoting keep full or scheduled delivery, knowing what your company policies for out of gas situations, gas smells, or gas leak calls, always make those a priority. Understand that duty to warn involves everyone and keeping your customers informed. Always inspect entrance and exit points at customer locations or new customer locations. Make sure they're safe to travel in and safe to travel out. Here's a tip when it comes to installing new regulators. At the same time, always use a new pigtail. Older pigtails over time can develop copper sulfate on the interior of the pigtail, which will flake off and possibly plug up the seat disc at the regulator inlet. If this happens, there's a high probability that creeping will occur. In other words, the seat disc will remain partially open against the inlet nozzle. This can cause issues with regard to high pressure downstream and ultimately the relief valve on the regulator opening in some cases. The same thing can happen to copper tubing being used inside or outside of the building supplying appliances. Always make sure that that copper tubing, if moved or bent, is cleared of any debris or copper sulfate that could have accumulated inside the tubing before connecting to the gas control and ultimately plugging up the inlet of that gas control. What happens in those cases of a persistent gas smell? In other words, when a gas leak check is done, but no leak is determined or found. It could be a dead animal somewhere in the wall or behind the appliance. It could be a sewer gas problem, or it could just be a smelly basement or crawl space. Consider this. When a leak check is done, the gas controls are in the off position or are turned off. So therefore, the pilot light is not on, the gas valve itself is not pressurized, at least the outlet side of that gas valve. Oftentimes, if we don't check the pilot tubing or ferrules, the pilot assembly, or even the gas valve itself with regard to the seals or gaskets, we find that a leak could be occurring there. In other words, we do the leak test proves or checks out fine, and then we light the system back up, only to find out that the pilot tubing is leaking. That pilot tubing leaking cannot be picked up on a conventional leak test. It must be sprayed down at every leak check. Leak checking with a liquid leak detector at the pilot tubing and ferrules and the vicinity of the gas valve will eliminate the possibility that any of those are leaking and contributing to the gas smell. If you install or service vent-free propane appliances, it's important to understand and also educate the consumer that for every gallon of propane burned, nearly 1 gallon of water vapor is produced. Oftentimes, this can be a benefit in the winter months when it's dry. However, it can also create an excessive moisture issue inside the home if the vent-free appliances are not sized properly or installed properly. Sometimes sooting in the vicinity of a vent-free appliance can be mistaken for a defective appliance or an improperly burning appliance. One answer to that buildup of soot around the vent-free appliance may be that the consumer is using or burning candles in the building or in the home. Oftentimes, candles will emit a microscopic soot particle, particularly with the lesser expensive candles. The better the quality candle, the less microscopic soot particles will be emitted. The moisture that's being emitted from the vent-free appliance will actually allow the microscopic soot particles to adhere or stick to it and give the illusion, in some instances, that the appliance is actually contributing to the soot, whereas it could be more of an environmental issue. In the case of a vent-free log set, another issue could be the improper placement of those gas logs. Proper placement of vent-free gas logs on a vent-free burner is critical. The instruction manual in most any vent-free log set include detailed instructions on where to place certain logs. In many cases, it's color-coded, and also the logs are actually numbered to go on the vent-free burner in a certain order. And speaking of vent-free appliances, when it comes to cleaning ODS or oxygen depletion sensor pilot assemblies, always steer clear of dusters or canned air. It's not recommended. It's not recommended simply because it generally contains a flammable propellant, sometimes propane. Instead, try using a piece of copper tubing and manually blowing out that pilot assembly. Understand that static electricity can be a big deal. Always make sure that your transfer areas are grounded, your bulk transfer connections are grounded. Make sure that anyone using or operating within a transfer area has the proper PPE or personal protection equipment. And also make sure that you're wearing the proper footwear, static resistant footwear to be exact. The NFPA 58 handbook has a static electricity supplement that's highly recommended. Thank you for watching this presentation on doing some of the little things that make our environment and our industry much safer. Hopefully you picked up a few pointers and can share those with some of your colleagues. Thanks very much and have a safe day.